So guys, our first question, part A, is asking us to complete the table. And we have been given the subatomic particles, and we have been asked to deduce the charge and the relative mass of each of the subatomic particles. We have already been given the charge of a proton and the relative mass of a neutron, and we have been asked to determine the charge of neutron and electron and the relative mass of proton and electron. So in this table, you can see here clearly proton has a relative mass of 1, neutron has a relative mass of 1, and electron's mass is almost negligible. It has a mass of 1 over 1840. In terms of charges, proton has a positive charge, which is a +1. Neutron is neutral, it has a 0 charge, and electron has a negative charge, which is a -1. So for this part of the question, we just input these values into the table. So neutron has a charge of 0, right? Electron has a charge of -1. In terms of relative mass, proton has a relative mass of 1, neutron has a relative mass of 1, electron has a relative mass of 1 over 1840. So we are done with the A part of the first question. Moving on to B part. So our part B of the first question states that the following are isotopes of carbon. So there are 3 isotopes of carbon given here. And it's asking us in terms of protons, neutrons, and electrons, how are these 3 isotopes the same and how they are different. So it's a 3-mark question. So to secure 3 marks, we need to give 2 details. So from the definition of the term isotope itself, the answer is being given. So you can see here, if you see the definition of the isotope, so what are isotopes? Isotopes are atoms of the same element that contain the same number of protons and electrons, but a different number of neutrons. The symbol for an isotope is the chemical symbol or word followed by a dash and then the mass number. So example of the isotope can be C14, which is isotope of carbon, which contains 6 protons, 6 electrons, and 14 minus 6, which is 8 neutrons, mass number minus the atomic number. But now we'll stick to the question. They're asking us what is same in these isotopes and what is different in these isotopes. So from the first point, you can deduce that they contain, in terms of they are atoms of the same element that contain the same number of protons and electrons. Okay, so for the first part, they're asking the same because they contain the same number of protons and electrons. So I can write here, they are same because they contain the same number of protons and electrons and why they are different. So we have secured 2 marks here because we have mentioned they contain the same number of protons and electrons. And why they are different? They are different if you see the definition again. You can see here, but a different number of neutrons. So what are the difference in these isotopes? It is the neutrons, because they add mass on these are neutral particles which will add mass within these isotopes. So we can just simply say they are different because they contain different numbers of neutrons. So we have secured 3 marks. I recommend you, before you ever solve any question, just read the mark of the question carefully, so you will get an idea of how much detail you need to provide, how much points you need to give to the question to secure full marks in that question, in that particular question. Moving on. Why do all isotopes of carbon have the same chemical properties? So this is a 1-mark question, and we are being asked why these isotopes of carbon have the same chemical properties. So you need to be familiar with the statement that why isotope share properties. These isotopes of the same element display the same chemical characteristics. This is because they have the same number of electrons in their outer shells. This is the point we are looking for. This is because they have the same number of electrons in their outer shells, and this is what determines an atom's chemistry. The difference between isotopes is the neutrons, which are neutral particles within the nucleus and add mass only. So the difference between neutrons is only the mass, and the similarity, why they share properties, this is because they have the same number of electrons in their outer shell. Okay, so this is the point we are required to give in order to secure a mark. Simply, we can write here This is because they have the same number of electrons in their outer shells. Name two forms of elements. Part C. Name two forms of the element carbon which have giant covalent structures. So if you are familiar with the concept of macromolecules, this question would be super easy for you. So we have discovered, so we are already familiar with the concept that giant covalent concept of giant covalent structures, and you already know that diamond and graphite are allotropes of carbon which have giant covalent structures. So we are focusing on the first point here. What are the allotropes? Allotropes are different from same element. So carbon is that element, and we have different forms. The different forms that the two different forms are diamond and graphite. So we can simply write in this part of the question as diamond and graphite. Okay, these are the two forms of the same element carbon which have giant covalent structure. These are the two different forms we are mainly looking to. So we can write here diamond and graphite. Diamond and graphite. Diamond and graphite. One minute, guys. Yeah. Perfect. Moving on to D part, complete the diagram to show the electron arrangement in a carbon dioxide molecule. Show the outer shell electrons only. So for this part of the question, you need to be familiar with all the electron arrangements in complex molecules as well as in simple molecules. Now we're looking at a complex molecule, which is carbon dioxide, and you already know that carbon dioxide is a covalent compound, because covalent compound only involves non-metal atoms, and thus they share electrons. And you can see the sharing is happening. The carbon dioxide and oxygen atoms are sharing electrons, and this will be the electronic structure you are required to draw in your examination paper, so you can secure a 1 mark. No, you can secure 2 marks. Now moving on to our second question. This was the end of the first question, and we are starting with the part A of the second question now. Beryllium is a metallic element in group 2. Give the electronic structure of a beryllium atom. Moving on to our second question. Our second question states that beryllium is a metallic element in group 2. Our part is asking us to give the electronic structure of a beryllium atom. Now we already know that we can represent the electronic structure of any atom in two ways. The first way is using the electron shell diagrams, and the second way is using the electronic configuration. Now in this question, we have to use the electronic configuration method. So if you see this table, you can see here clearly all the electronic configurations for 1 to 20 elements are given here, and they have also given the atomic number. Why this atomic number is given here? Let me just tell you. Now this atomic number has a very important role when we are writing or we are deducing electronic configurations. For example, this atomic number will decide how many electrons will be there in total for that particular element. For example, hydrogen has an atomic number of 1. This means it will have only 1 electron in total. Helium has atomic number of 2. This means it will have only 2 electrons in total, and so on. Now we are talking about beryllium here, and beryllium has an atomic number of 4. Okay, this means it will have only 4 electrons in total. Now how we will write the electronic configuration? How this electronic configuration will be deduced for beryllium atom? Now if you see this diagram, you can see here the arrangement of the shells, the arrangement of the electrons in the shells, how these electrons are arranged in these shells. Now each electron shell can accommodate a fixed number of electrons. Okay, there's a limited number of electrons these shells can accommodate. The first shell can hold up to 2 electrons. The second shell can hold up to 8 electrons. The third shell can hold up to 8 electrons, and the rest of the shells can also hold up to 8 electrons. Okay. Now you can see here, beryllium is in it has 4 electrons in total. This means the first 2 electrons will go in the first shell, and the second shell will hold the rest of the electrons, because the second shell will also hold 2 electrons. So our electronic configuration for this atom will be, for this element will be 2, 2, and you can see here clearly beryllium, the electronic configuration is 2, 2. So we'll just write here 2, 2. Moving on to part B. Okay, so for this part of the question, which is the part B is asking us to give the formula of beryllium oxide, and for this part of the question, you need to be familiar with the valencies of each of the groups. Okay, So here you can see clearly in this periodic table I have given here. So group 1 has a valency of +1, group 2 has a valency of +2, group 3 has a valency of +3, group 4 could be +4 or -4, group 5 is -3, group 6 is -2, group 7 -1, and group 0 is 0. Now moving on, these type of questions we have in our previous past papers also. You can just go check out that videos. Anyways, so how will determine the chemical formula of beryllium oxide? Firstly, we need to know the elements, we need to know the chemical symbol of the elements which are present in this compound. Okay, so we can, from the name itself, we can determine which are the elements present here. So beryllium oxide, we can say beryllium is the element and the oxygen is present in this compound. So our first step, what we need to do, we need to write their chemical symbols, plus we need to write their valencies first. This is the first step we need to do. Actually, it's a 1 mark question. They're asking for direct answer, but for you, I'm giving you the detail of how we will determine the chemical formula. So firstly, you need to write the chemical symbol and their valencies alongside. Okay, it's in group. You can see here, it's in group 2, which has a valency of 2 plus. Okay, and oxygen has the chemical symbol of O, and it has a valency of 2 minus, because if you see that if it's in 5th group, right, you can see here it's in 5th group and it is a valency of -2. So it has, we can write here the 2 minus. Now our next step, what is the next step? Again, we need to rewrite the chemical symbols, but this time we need to swap their valencies, okay, with each other, and there we have to ignore their signs. Okay, so let me just tell you how I'll do it. I'll rewrite the chemical symbols, but this time I will not write the valency of beryllium atom. I will write the valency of this O2 minus, but I have to ignore the sign. So okay, so it will be like there's a 2 plus and 2 minus, right? So we can write here BE and O. Okay, we need to write something like BeO. Leave some space. Now, how we will determine the charges? What will be the charge? What will be the numbers present here? Actually, there will be no numbers present here. Why? Because they have the same charges and it is opposite charges, right? 2 plus and 2 minus. And we already know that opposite charges will cancel out. So we'll get the simple formula as BeO, beryllium oxide. This is the formula for beryllium oxide, BeO. This was the, so we are done with the part B of the question. Moving on to part C. Describe the bonding in metallic elements such as beryllium. Include a label diagram in your and any appropriate charges in your answer. It's a 3 mark question. In order to secure 3 marks, you need to draw the diagram and you need to give a label diagram and you need to mention some information about that. So you can see here I have already given. And these questions are also came in the previous past papers, as I remember. And you can see here how we'll draw the structure of this. 1 minute, guys. This type of question has come multiple times in our previous exam papers. In all the exam papers I've solved, this question is like almost mostly present in all my previous past papers. If you see the previous past papers, you can just check it out, the question. Anyways, what would the diagram will look like in metallic? When we are talking about metallic elements, we need to be familiar with this structure. So in your exam, if you are given this type of question, the bonding in metallic elements such as beryllium, and we should include label diagrams. This diagram you are required. With labeling, you need to give positively charged metal ions, and you'd also give electron, the delocalized, they are free to move throughout the structure. Electrons from outer shells of atoms you need to give here. Label this diagram in order to secure your 3 marks. And this you need to show their movement, how their movement also you need to show, and they should not be touching each other actually. Okay, just you have to leave some space between each other, the electron and the positive charge or the negative charge. You need to leave some space, and their movement also you need to show how they are moving, their behavior while moving. And you also need to give a statement, and what statement you are required to give here you can see here. Now let me just show you. Yeah, now these metallic bonds, this is the metallic bonding, and these metallic bonds are strong and are results of the attraction between the positive metal ions and negatively charged delocalized electrons. So this diagram with the labeling and this statement you are required to give in order to secure 3 marks. I hope you're getting me. Moving on to our next part of the question, explain why metallic elements such as beryllium are good conductors of electricity. So for this part of the question, you need to be familiar with the concept of the metallic bonding, metallic bonding, and the properties of metals. So you can see here the 3 different properties of these metals, and we are mainly focusing on the second point we just highlighted. We are just focusing on this point, right? Metals conduct electricity. Why they conduct electricity? Now these metallic elements will conduct electricity because there are free electrons available to move and carry the charge. Electrons entering one end of the metal causes a delocalized electron to displace itself from the other end. Hence electrons can flow, so electricity is conducted. So we should give, it's a 1 mark question. In order to secure 1 mark, we need to give this point. There are free electrons available to move and carry the charge. This is the point we are required to give in order to secure this 1 mark. So I'll just input this here. Okay, there are free electrons available to move and carry the charge, and you have secured 1 mark. Moving on to part D. Beryllium hydroxide is amphoteric. 1 minute. Yeah. Beryllium hydroxide reacts with acids. The salts formed contain positive beryllium ions. This part of the question is asking us to give the formula of the positive beryllium ion. What would be the formula of the positive beryllium ion? So if you see the valency chart again, let me just show you valency chart again. Yeah, here you can see beryllium is in group 2. It has a valency of +2. So how you're required to give here? So simply you will write here the chemical symbol. First is the chemical symbol, and you have to give the valency along this. Okay, this will be the simple answer. You have secured your 1 mark. Moving on, write a chemical equation for the reaction between beryllium hydroxide and hydrochloric acid. So let me just show you the chemical equation. Now you can see, before we are giving the chemical equation, the question is at the beginning itself, it's giving us that, stating that beryllium hydroxide is amphoteric. Now what is meant by amphoteric? Amphoteric oxides, these are a curious group of oxides that can behave as both acidic and basic, depending on whether the reactant is an acid or a base. In both cases, a salt and water is formed. Okay, so you can see here a chemical equation for the reaction between beryllium hydroxide and hydrochloric acid. Now what they told here, it can behave as both acidic and basic, depending on whether other reaction is an acid or a base. So we can see a beryllium hydroxide, we don't know whether it's an acid or a base, and here they have given the other reaction, this is an acid. This means beryllium hydroxide will behave as a base in this reaction. So acid will give you a salt and water. This is the neutralization reaction, and the chemical equation is given here. And I every time tell you that whenever they ask you for a chemical equation, you need to balance it. Okay, otherwise you will lose that mark. And every mark is precious in IGCSE exams. Okay, so this is the equation, the chemical equation you're required to give. Make sure everything is balanced before you move on to the next question. Okay, I'm checking beryllium. There was 1 atom of beryllium, 1 atom of beryllium. Oxygen, there are 2 atoms, and you can see here also oxygen has 2 atoms. Hydrogen, there are 2 atoms. Yeah, and here they have 2 more hydrogen atoms. 2 plus 2 is 4, and here also we have 4 hydrogen atoms on the product side. Okay, and there are Cl atoms. We have 2 Cl atoms here and 2 Cl atoms here. Done. Balancing. Moving on to the next part. Beryllium hydroxide also reacts with alkalis. The salts formed contains berylate ions, BeO2-. They have given the ion. Right, so this is a chemical equation for the reaction between beryllium hydroxide and sodium hydroxide solution. Now we already know that beryllium hydroxide is amphoteric. Okay, and amphoteric oxides can be acidic or basic, depending whether other reactant is an acid or a base. And for this part of the question, you can see sodium hydroxide is the other reactant, and we already know that sodium hydroxide is a base. This means in this part of the in this reaction, now beryllium hydroxide is behaving as an acid. Again, it's a neutralization reaction. We'll get 2 products, the salt and water. And what will be the reaction here? Now this beryllium oxide will react with sodium hydroxide to produce sodium metaberylate. and water. Actually, in these exam questions, you won't be asked to give the formula of this type of questions. Okay, but you need to be familiar with the chemical formula because this is the most often these questions are asked in your exam. So I recommend you to learn to practice as much as possible as you can, because the advantage of solving these past paper is that these questions are repeated every time. Okay, anyways, we'll stick to the question. This is the chemical equation we are required to give. Make sure everything is balanced in the product side as well as on the reactant side. So I'll just mention here. Done. Okay, everything is balanced. Already checked. Moving on. So this was the end of the second question.